I'm doing great. My whiteboard link is acting funny. Hey, Logan. Good afternoon. We'll get started in just a little bit. Probably right at 3 o'clock. Hey, Megan. We got a whole lot of problems left, so I have looked over them to try to find all the quickest ways to explain them. So hopefully we can get to number 60. That's definitely the goal. Hey, Jameis. One of my granddaughters has a project to do tomorrow on the 5th grade. They're doing their states. Each student gets a different state, and then they have to talk about it. People have to come into the gym or whatever. What's up with you? Not much here. Anyway, my daughter just sent me a text that said, hey, Mom, can you print off all those things about Alaska? So it will be interesting, Z, but it'll probably be about, y'all know how much ink cartridges, no telling how much stuff they want printed off. So it's going to be interesting, but I know my ink is probably low. So I figured I would just start printing until it ran out of ink and then go to the store later. I had already texted myself. I don't know if y'all do that, but I text myself reminders and it says ink, get ink. So when I'm out running errands this afternoon. Hey, Xander. Alaska will be interesting. I'm sure I'm going to learn all kinds of things about Alaska that I did not know. My whiteboards are so big for these because it's just a lot of slides. It's acting a little funky. So I'm having to redo it really quick. All right, 5 minutes and we're going to get rolling. Going to try to work as fast as I can to try to work the rest of these 60 problems and hopefully 45 minutes. It might take me longer than 45 minutes. Those catch-up days I know are nice, Megan. I'm telling you, that's a hard part about virtual is I can just tell you from teaching in person for 30 years. Sometimes if a class didn't get something, I went over it again the next day and I didn't just go to the next section. So virtual is, we schedule all that at the beginning of the semester and it has to be assigned each day. I know sometimes y'all don't get to it each day, but anyhow, yeah. Definitely if you're trying to keep up, I mean it's not always easy to do. But yeah, that Friday catch-up day and then that Saturday, Sunday, if you need it, can make the next Monday a pretty good day. I keep a little list. I have a calendar and it's by day, and then I put everything down that I want to accomplish for the day, and then I check it off. And then if there's something I don't get done, I just move it to the next day. And so I just constantly trying to do every single thing. So kind of like life. And then when you have extra time, I like to work ahead. So, when something comes up that you're not expecting, you're ahead. And then, maybe you have some wiggle room. But it's almost 3 o'clock. That's when I have my afternoon caffeine. Maybe I should go ahead and grab it. I think I can make it. I'm going to hold off till 4. My body knows 3 o'clock. I've really stopped drinking a lot of caffeine in the mornings. I probably only drink like half a cup of coffee. All right. I'm going to go ahead and give y'all a whiteboard link. We'll kind of get the party started a little bit. We've got about 2 minutes. So when I initially set up this help session 2 years ago, I did split it up into a part 1 and a part 2, and then I probably didn't get it all finished. So this is going to say part 1 because we're still in the first 30 problems. And I have a note that we are either on to number 26 or we just did number 26. I bet somebody in here can tell me. We're either on problem 26 or 26 was the last one that we did. I have a little star beside 26. 26 is the one we're going to do next. I remember doing 25 last. Hey, Isabella. So I'm going to go ahead and share my screen. So again, this whiteboard deck does say part 1, but that's because I split it up into the first 30 problems and the last 30 problems. So once we get finished with number 30, then I'll give you the whiteboard link to the second deck that starts with 31 and goes through 60. So we'll switch whiteboard decks in the beginning of this lesson. And that's just how we're going to go with it today. All right, I am recording. I'm going to share my screen. We've got 1 more minute. And then we're going to hit the ground running with problem number 26. And then I'm just going to work. I'm going to work at a fairly fast pace because I do know I have, 24 problems to work out. There's a few of them. If you weren't here earlier, I did try to go over, hey Alexis, I did try to go over everything that I'm going to talk about today to try to find the easiest way to explain it. Sometimes I tend to think, hey Natalia, I tend to make a problem more difficult than it is. Okay, it's 3 o'clock. I'm getting started with number 26. Number 26 says about 1.48 times 10 to the 8th square kilometers of the Earth's surface is land. The rest, about 3.63 times 10 to the 8th square kilometers, is water. If a returning space capsule lands at a random point on the Earth's surface, which of the following is the best estimate of the probability that it will land in water? Okay, so what I did is, this is the total. And this is the land. So it says, what is the best estimate that the space capsule will land in water? Let me read that again. Earth's surface is land. Oh, this is land, excuse me. And this is what's left. So this would be water. So we're going to do, what is the estimate of the probability that the space capsule would land in the water? So we're going to do the water out of the hole, or out of the land, excuse me. And then I would put this into, this is scientific notation. It should look familiar to you. Use it in science and math. I would probably just put this in a calculator. Hey, Huda, we are starting with number 26, and we are just going to go until we can try to get to number 60. If we divide this out using a calculator, it's going to give us 0.71. Anybody, which is, excuse me, 71%. Anybody need me to show you how you would put scientific notation in a scientific calculator? There may be a good chance, since these are both 10 to the 8, you probably can forget about the 10 to the 8 since they're both 10 to the 8s. 363 divided by 1.48. No, 3.63 divided by 1.48. 2.45. Oh, my bad. The bottom is wrong. I do hear somebody's mic on. I don't know if you're trying to talk or it's accidentally on. My bad. This is land. So we're doing the percent of water. So we actually have to add the land with the water. So that has to be on the bottom. That's why I didn't get the answer that I told you it was. So definitely I would use my calculator for this. So I'd put this number in the top. I would put the sum of these numbers in the bottom, and you would just type it in 3.63 times 10 to the 8th, and then everything in the bottom. You can, Z. I'm going to try to work all these problems, and then if you don't mind, I'll read your private message in just a second. Okay, questions about 26. So we did the water over the whole earth, which would be the land plus the water. And then they make it a little bit harder there because they're giving you the numbers in scientific notation. So again, I'm going to look down. If you've got a quick question, you can put it in the chat. Megan says, why do you have to add the land and the water? Because it wants to know, it says, what is the following, the best estimate of the probability that it will land in water? So you've got to do water out of total. When you're doing probability, you've got to do that out of the total. And in this particular problem, we're talking about the total earth. So that would be land and water. They gave you the square kilometers for the land, and they gave you the square kilometers for the water. So if they say, what's the probability that you're going to land on water, then you have to do water out of the total. All right, cool. All right, number 27.
Hey, Miss Prater.
Hey.
I just wanted to say I am so thankful I'm taking Algebra 2 this year, because Lord has it helped me when doing the ACT. Like, I'm having, let's just say I'm coming across more questions on the ACT that regard Algebra 2. And in the past, if you gave this to me, I would have done things in a completely different way and wasted so much time. But now, immediately when I see a question like this, in a matter of seconds, I know what to do.
Thank you for mentioning that. So 96% of what's on the math part of the ACT is going to come through your Algebra 2 course. And so what Huda said does make a lot of sense that, oh, you know, you're gonna see 96% of what's going to be on the ACT is going to come from whatever you've taken all the way up through Algebra 2. Number 27 says, on the first 7 statistics test of the semester, Jamal makes these following scores. And so I rewrote them down here because I want to show you something on this particular problem. So he made these 7 scores, 1, 2, 3, 4, 5, 6, 7. It says the mean. So quick reminder that mean is average. Median is the number in the middle once the numbers are in numerical order. Mode is the number that occurs the most. You might remember this from like 6th or 7th or 8th grade. So it says the mean, median, and mode of his scores were 79. So his median was 79. His mean, which is average, was 80. And his mode, which is the number that occurs the most, was 80. So his average and his mode were the same. So it says on the 8th test, Jamal scored a 90. So that means we're going to add in, on his 8th test, he's going to score a 90. How does the mean, median, and mode of all 8 of his scores compare to the mean, median, and mode of his 7 scores? So to me, this is not a drastically difficult problem, okay? But the fact, it's just you have to read through the problem. You got to get through the wording. And then if you look at the answers, they're comparing, did the means, are they equal or greater? They're going to compare the median and the mode. So we're comparing. It says all 8 of his scores to his 7 scores. So let's take a look at the first 7 scores. So we know, okay, if we look at the first 7, they're the ones in the pink. They've already given us the statistics for those. So if you think about median, so if you go 1, 2, 3, 4, 5, 6, 7, median is the number in the middle, so it's going to be 80. If we add the 90, then 80 and 80 will be in the middle, and the median will still be, oh, wait a minute. Was the median? Oh, I wrote these wrong. Hold on. All right, they're giving us mean, median, and mode. Or 79, 80, and 80. Okay. I'm like, the median is not 79. All right, so the median is not going to change because if we do the first 7 numbers, this 80 is in the middle. If we add the 8th number, the 2 80s are going to be in the middle, and that's when you average those 2 middle numbers and you still get 80. Okay, so the median is not going to is not going to change. So it's going to be equal. So that means we can eliminate A, B, and C. So what else do we want to look at? If we, the average, you think the average is going to change if you add a 90 in? If the average right now, the mean, it means average. Yep, the average is going to change. It's going to go up a little bit, okay? So the mean is going to be greater, and both of these are greater, so we're still on D or E. Okay, so the mean is going to go up. We've done the mean. We've done the median. And the mode. The mode is the number that occurs the most, and it's still going to be 80 because we added a 90, and there's only one 90. So that one's going to be equal, and that's how we pick E for that one. So you kind of got to process that one. I think that would probably take you more than 60 seconds if you're kind of thinking 60 problems, 60 minutes. You know, that one's not hard. It's just going to take some time. Not hard compared to some other ones that I think they're a little bit harder. All right, 28. The solid rectangular prism shown below was built by alternating congruent black cubes and white cubes such that 2 cubes of the same color have at most one edge touching. What is the total number of white cubes that were used to build this. So what I did is I counted one, come on, pen, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And I did volume. Volume is length times the width times the height. So that's going to be 7 times 5 times 6. And I already got that worked out. I got 210. And they want to know the volume of the white cubes. Well, there's just as many white cubes, there we go, Huda, as there is black cubes. So I would just divide that by 2, and then that's going to give me 105. So I would find the volume of the whole thing, and then half of it's going to be white cubes, half of it's going to be black cubes. Moving to number 29, I'll keep glancing at the chat, but again, we've got a whole lot of problems to work, so I'm just going to roll with it. Number 29, one side of a square ABCD has a length of 12. A certain rectangle whose area is equal to the area of ABCD has a width of 8. What is the length in meters of the rectangle? So I have a square. You don't have to draw a picture. I'm visual, so I have this square. I have this rectangle, and I'm not drawing these to scale. The area of the square is 12 times 12 because we do base times the height or length times the width. So that'd be 144. And it's telling me that the width of my rectangle is 8. And then I'm looking for this. So whatever this number is, it's got to multiply by 8 to give me the 144. So you could do 144 divided by 8. And that's going to give you 18. So this side would have to be 18. Because 18 times 8 is going to give you 144. Or you could look at your answers and say, what times 8 is going to give me that 144? You could kind of do it that way. Very much, several of these are similar, you know, throughout every time the ACT is given. Every once in a while, they're going to start changing it up because they're going to try to make the test relatable. They're going to try to make it, you know, a little bit difficult. If students keep getting the same answer right over and over again, they might switch that out. I mean, I've seen that happen. Number 30 says the average of a list of numbers of 4 numbers is 92. So the first thing that came into my mind is that I have 4 numbers. When I add them up and I divide by 4, I get 92. So this is the numbers added up, the sum of the numbers. A new list of 4 numbers has the same first 3 numbers as the original list, but the 4th number is 40. Okay, so what I did is I multiplied both sides by 40, and you could think of this a little bit different. 92 times 4 is 368. And then I said, I'm going to take out 40 because it says, but the 4th number of the original list is 40, and the 4th number of the new list is 48. So if I take out the 40, that's going to give me 328. And now, instead of adding 40, they're going to add 48. Or you could have added 8 to 368. That's going to get you the same number. That's going to give me 376, and then that's the sum. So then we're still got 4 numbers. We're just replacing the 40 with a 48, and then I ended up with 94. Let's double check that. 376 divided by 4. Yeah. You might could have thought it a little bit different, maybe in a little bit different steps, but I still think you got to use the 92. You still got to multiply by 4. You got to take out the 40, add the 48, and figure out what the average would be there. All right, we're going to switch to this whiteboard only went to number 30, and the other one is going to go from 31 to 60. So I'm going to give you this new link. So if you want to save the whiteboard that you're working on, you can, or if you're not working on a whiteboard at all, just ignore what I just said. Once you get into that whiteboard, you're gonna go to slide 13, where number 31 starts. Again, this is our third session. I am going to send out an email probably tomorrow with all 3 recordings in it. No problem for being late. We are working on problem 31. All right, 31. This is a physics problem. You're also going to do a little bit of 31 next year if you take pre-calculus. So 31 is not something I teach you in Algebra 2. I don't think you learned about 31 prior to Algebra 2, so you might not know how to do 31. But hopefully after going over this today, you're going to go, okay, that wasn't that hard. It was just something I'd never done. So 31 says the vector I represents 1 mile per hour to the east. So I represents to the east. So this would be to the east. This would be I. And then it says vector J represents, and a vector basically is a ray portraying direction. Sometimes it's force. That's kind of about all you need to know. J represents 1 mile north. So if we go up 1 mile north, that's going to be J. So remember, I was east. J was north. And this says Maria is jogging south. That's important because south is opposite of north. If north was +1, then south is going to be negative, and it's going to be 12 because it was 12 miles. And then J was connected with north and south. So this one's going to be -12J. There's really no work involved here. You just got to know that vectors have something to do with direction. So if they say 1 mile north is J, then 12 miles south is going to be -12J. All right, number 32. Says 4 identical glasses are shown below. 1 glass is empty and the other 3 glasses are 1/4, 1/2, and 4/5 full of water. If the water were redistributed equally among 4 glasses, what fractional part of each glass would be filled? So what I did is, this is 1/4 per the directions. This is 1/2, and this is 4/5. So I added these together and I divided by 3. So if you wanted to use a calculator here, you could. 1/4 plus 1/2 plus 4/5 divided by 3 is going to give me 31/80. Scientific calculator would really help you out there. And so if we divided this evenly, oh, wait. Not divided by 3, divided by 4, my bad. I bet some of you are going, what is she talking about? Yeah, we're going to put it back. Since this one is empty, we're going to redistribute this where we have 4 equal cylinders. So we would divide by 4, not 3. That was totally my fault. All right, moving to 33. We can go back at the end. Again, I really want to try to get all 60 explained, and then we can go back if you have a certain question. You can definitely go back and watch the recording. All right, number 33. Aurelio, if that's how you pronounce it, is purchasing carpet tiles to cover an area of his living room floor 8 1/3 feet. So again, I am a visual person, so I drew a rectangle. This is kind of a crappy rectangle. 8 1/3 feet and by 10 feet. Those numbers are going to be important. Each carpet tile square 20 inches wide by 20 inches long. So inside here are going to be little squares that are going to cover this big area. So each, oh man, my whiteboard recalculated. Let's see where we're at. I don't know if I lost my, oh, I didn't lose my writing. Awesome. Okay. Each individual square is going to be 20 inches by 20 inches. Now, the first thing that my brain is thinking is they're giving me the room in feet, but they're giving me each carpet square, each little piece that they're going to put together. It might not be carpet. It is carpet. I was going to say I made that up. They're giving me the size of that carpet square in inches. So I either have to turn the inches into feet or the feet into inches. So I chose to turn the feet into inches because I know that there are 12 inches in each foot. I'm going to multiply both of these by 12. And the 8 and the 1/3 ends up being 100 inches. And the 10 times the 12 is going to end up being 120 inches. And then what I did is I found the area of my rectangle, my big room, whatever I'm doing, by multiplying the base times the height. So I did 100 times 120. That gave me an area of 12,000. And then I have to find the area of one little square of carpet. So that would be 20 times 20. So that would be an area of 400. And both of these, if we were being technical, are inches squared. But we got to just come up with the answer. How many of these little squares are going to fit into here? Add, subtract, or multiply, divide. What do you think? If we know each square is 400, how many 400s are going to be in 12,000? We're going to divide. So we're going to take 12,000. We're going to divide that by 400. And that's going to give us 30 squares. So we're going to need 30 squares. So in this problem, they're probably checking to see, did you know that you had to convert to the same unit of measure? You've got to use area, plus you got to go a little bit further than that. Number 34 is a geometry problem. I do not know if you remember studying equations of circles in geometry. A lot of students, honestly, we just don't remember a lot of geometry. Some of you might, but we actually have a formula for a circle. It's x minus h squared plus y minus k squared equals r squared. What's the h and the k? The h and the k is going to be the center of your circle, and the r is going to be the radius. So if we go back and read the problem, in the standard xy coordinate plane, a circle with a center of 8, 5. So that means my h is going to be 8, my k is going to be 5, and a radius of 9. And so you're just plugging into your h, your k, and then your radius has to be squared in the equation. So I know it's not the ones with a 9. It has to be 81 because a circle always equals the radius squared. And then it's x minus h. So it's going to be f. It's going to be x minus the x in the ordered pair, which is h according to the formula, plus y minus the y in the ordered pair equals the radius squared. So 34 is just checking to see if you know the formula for the equation of a circle. So that means on the ACT, they're going to expect you have that memorized. They're not going to give you the formula. So you have to know x minus h squared plus y minus k squared equals radius squared. So you might want to be keeping up with a little list of some formulas that the ACT is going to expect that you know. So don't think they're going to give you every single formula and then you know you're not going to be able to Google formulas. So that's going to kind of put you in a situation. All right. Now, another thing that I know that I have trouble with when I'm testing is if I have a problem that has a lot of information and that information is used for multiple problems. Sometimes once I get towards the end, so once I get to 36 and 38, I forget that there was some information that is used for multiple problems. So kind of keep that in mind. It says many humans carry the gene. I'm just going to say YQ77. The YQ test determines with 100% accuracy whether a human carries the YQ77. If a YQ test result is positive, the human carries the YQ77 gene. If YQ test results is negative, then the human does not carry the YQ77 gene. Sam designed a less expensive test for YQ77 called the SAM77 test. It uses some incorrect results to determine the accuracy of the SAM77 test. Both tests were administered to 1,000 volunteers. That number is going to be really important. 1,000 people got tested. The results from this administration are summarized in the table below. So first of all, I would take a look at the table. This says positive SAM 77 test, negative SAM 77 test, positive YQ test, negative YQ test. Let me mention this. You have to stay out because I'm okay. I'm busy. I'm busy. Close the door. Sorry. Got grandkids here today. They know they're not supposed to open the door when my door is shut, but they do it anyway. Okay. This represents positive YQ test. This represents negative YQ test. All right, let's get to number 35. Remember, this information goes for 35, 36, 37, 38. All right, number 35. Hood has already given us some advice. It says it costs $2,500 to administer the YQ test, so very expensive. $50 to administer the SAM 77 test. What is the total cost of administering both tests to all the volunteers? So remember, they were 1,000, right? So 1,000 took the expensive test, and then 1,000 took the less expensive test, and then you would actually add those together. So straight up, use your calculator, and that's going to give you 2,550,000 E. So the 1,000 volunteers are taking both tests to try to determine the accuracy between the YQ 77 and the SAM 77 test. So that one's not very hard, okay, compared to the other ones in this little section. All right, so I put this information on every slide so I wouldn't have to flip back. So again, same information, new problem. 36 says what percent of the volunteers actually carry the YQ77. So there's probably a couple different ways you can do it. On this one, I did 615 divided by 1,000. Let's see where I got that. Here's the YQ test. If we add these two numbers up, we get 615. We know that 1,000 people took it. If we divide this out, we get 61.5. Actually get 0.615, and then we move the decimal 2 places to the right, and we get 61.5%. So again, not a super duper hard problem, but we have a lot of information to filter through. Number 37, for how many volunteers did the SAM 77 test give an incorrect result? All right, for this one, I got 35. So let me see if I can remember how I got 35. Oh, I added the 25 and the 10. Some people just get this problem. They can analyze a lot of material, but the YQ test, the more expensive test, said these were negative. And then the SAM test, here's the SAM test. If you run it this way, the SAM test said these were negative. Says how many of the volunteers did the SAM 77 test given incorrect? My bad. SAM said these were negative, and they were actually positive. So I think that's how I got that one. I don't know. This problem, probably out of all 60, I don't know why, but this one confuses me. I'm going to put a little frowny face there. Sometimes a problem just confuses me, guys. I probably could not get every single problem of the ACT correct. So I don't want you to think that's the goal, to be able to go in there and get all 60 correct, because sometimes no matter how much math you know, there'll be something that is just confusing. So remember, skip it, move on, do all the ones that you can, do the best you can. Try not to be anxious. You know, it's not a life or death test. You can take the ACT again if it's something that you need to go to college. 38 still goes with this set of directions, so don't forget that. 38 says one of the volunteers whose SAM 77 test result was positive will be chosen at random to the nearest 0.001. What is the probability that the chosen volunteer was not, or did not, or does not possess YQ 77? So for number 38, I did, let's see, I looked at 590 and 10, and I took the 10 and I did it out of this total. And then when I do 10 divided by 600, that gives me 0 point, and they're saying 1, 2, 3 places to the right, so 0.0 1, 6, and then it's got a 6. And so this is the place that we're rounding to. So this 6 is going to round that up. So I'm going to get 0.017, which is that first one. Yeah, and y'all can go back and look in your whiteboard deck, 23, or who might can look at it without me going back, about how many, what's the range of correct math problems to get the 23 in math. I think that 23 is probably an average of everything, but can you tell us out of 60 problems, what's the number correct for 60?
Well, it varies depending on who's grading the test, because some people grade it different than graded different than others. Like in some tests, you get a 24, but others would consider it a 23. But let me check
since it's multiple choice. Yeah, there's a raw score table either in that first whiteboard deck that I sent you, but if you look at the math, it'll tell you how many you have to get correct for a certain score, and it'll usually be a range of correct numbers for that score. All right, 39 is actually something we're going to do this semester in Unit 8, and it's multiply matrices. Huda mentioned this the other day. She said, man, I'm having a lot of trouble multiplying matrices. It's just something that you've never done before. James mentioned something.
I found it. According to the ACT official prep guide, you need to get at least a score of 23, 32 to 34 questions correct in the math.
All right, 32 to 34 correct gives you an ACT score of 23. And each subtest, so reading is different than math. You'll have to look at the way that is set up. So, 23 is a really good ACT score, and that means that you're going to miss a little bit less than half the problem. So, I don't think the test is really designed for you to get every single problem correct. All right, when we're multiplying matrices, first of all, I don't think you've ever done matrices before. You may have never heard of the word except the movie, The Matrix. But a matrix is an array of numbers that are listed in rows and columns. And when we add them and subtract them, it's going to make complete sense. But when you multiply them, it's kind of the weirdest thing that you've ever seen. So when we're multiplying this matrix, this has 1 row and 2 columns, times this matrix, which has 2 rows and 1 column. Again, we teach this in Unit 8. It's just not going to happen before you take the ACT. The rule for multiplying a matrix times another matrix is you multiply the numbers in the row of the first matrix times the numbers in the column of the second matrix. So that means the -1 is going to be multiplied times the -2. And then you're going to combine that with the 0 being multiplied times the -1. So it's going to be this times this plus this times this. -2 and -1 multiplied to be +2, 0 and -1 multiplied to be 0, and then you're going to add those, and then that's what you get for the final answer. I would probably suggest that if you're really, really serious about trying to get a super high score on this ACT coming up in March, that you might either email me or YouTube. I've got a whole video on, or at least two or three videos on operations of matrices. So you can either look up operations of matrices, or you can send me an email and I'll send you a video that I've made, or at least one video on matrices. These are not difficult. It's just something that you've not been taught yet. Okay, adding and subtracting is super easy. Multiplying is not. All right, moving on to number 40. All the way on this page. Regardless of how the graph is oriented in the standard XY coordinate plane, no graph in one of the following categories has a vertical, so this is vertical, line of symmetry. This one, I just kind of thought it was scalene. You could sketch these out, okay? So if you think about a vertical line, if you think about a line, any line, and you think about drawing a vertical line, it would be, this side would be the same as this side. So symmetric, you could fold it over. Same thing would happen with a square. You could draw a vertical line and it would be symmetric. A pentagon would be symmetric, All of these would be symmetric except a triangle that has 3 unequal sides. So again, I know I'm going fast, but my goal is to try to get to number 60. Number 41, Algebra 2 problem, shout out. This is something that we've done this year. It says the equation given has 2 solutions. What is the greater of the 2 solutions? So you could do a couple different things. You could throw this equation in Desmos. You could use algebra. I'm going to use algebra because it's something that we've done this year. We know if we're solving, we have to set our equation equal to 0. So I'm going to subtract 15 from both sides. And then we're going to factor this left-hand side. Oh, if there's a GCF, you would want to factor that by dividing everything by the GCF, but there's not a GCF. This is going to factor into 2 binomials. The 15 is negative, so I know my signs are different. 24 is really big. They made this one hard, a little bit hard to factor. It's going to be 4x and 6x. The 4 is going to have the -3, and the 6 is going to have the +5. You could also do the quadratic formula. So let me talk about that really quick. That's going to be x equals -b plus or minus square root b squared minus 4ac over 2a. So here would be standard form. So you would use an a of 24, a b of 2, a c of -15. But again, you're going to have to know this quadratic formula. The ACT is not going to give it to you. If you know how to factor fairly well, you might want to choose factoring. If quadratic formula is more comfortable to you, you would use the quadratic formula. I'm going to finish the factoring. Once you factor, you're going to set each factor equal to 0, and then you'll solve these out. This one's going to give me +3/4. This one's going to give me -5/6, and it's asking for the biggest one, which will be the positive number. So we would choose A. Now, again, I probably even wouldn't work this that fast. Again, I'm just trying to get through number 60. If you graphed it, I will tell you that you might have to put a Y here if you graphed it. And then you would have to slide on your graph looking for where the graph crosses the x-axis. So if you graphed it, your solutions would be where the graph crosses the x-axis. So those are some things that you have to know. All right, number 42 is actually one of those 4% problems of something that we don't teach through Algebra 2. So this is actually a trigonometry problem that will be taught to you next year if you take pre-calculus. So at Alva, we do have some trig that we don't teach in Algebra 2 or we don't teach in geometry, and we shove it over into our pre-calculus class. So this is just something that you're not going to know. It's a formula. And so it says sine of 60 times cosine of 30 plus cosine of 60 times sine of 30. It says which one of these is this equal to. And so if you look at this like as an A and a B, I think this is the way the formulas are written. So if A is 60, B is 30, A is 60, B is 30. And then the answer to this one is, let me find the answer and then I'll walk it back. J. So you're not going to know how to do 42. If you look at something like this, you know, what's the chance that you have all these formulas memorized of something that you've not been taught yet? You're probably just going to have to skip this one and then go back and make sure you guess an answer for it. But this is sine of, it's this formula. So if you look at the breakdown, it says sine A times cosine B. So this is sine 60 times cosine 30 plus cosine A sine B plus cosine 60, which is your A, times sine of 30, which is your B, is equal to the sine of the sum of A and B. So yeah, I would say you're going to have to guess on this one. And you know, that's okay. All right, 43. What is the area in square units of a circle that has a circumference of 12 pi? So first of all, to this problem, you're going to have to bring the formula for circumference. So you could use pi d, or there's another formula that you might remember from 7th and 8th grade in geometry, which is 2 pi r. These are the same formulas technically because 2 times your radius is the same as your diameter. I would choose this one. because it's asking me for area. And you're also going to have to know the area formula for a circle, which is pi r squared. So the area formula has a radius in it. So that's why I'm going to choose this. So we know the circumference is 12 pi. We set that equal to the formula for circumference, which is 2 pi r. We solve for radius by dividing both sides by 2 pi. The pi's are going to cancel, and the radius is going to end up being 12 divided by 2, which is 6. So then I go into this formula, and I know that the radius of my circle is 6. So I'll plug that in to pi r squared. 6 squared is 36, and then I keep that pi. So I would choose 36 pi. I'd really, really like you to get a problem like 43 correct. But again, you can start adding to your think formulas that you're supposed to know. Here are some formulas in pink: circumference of a circle, area of a circle. We've done volume of a cube. We've done area of a rectangle. Those are all formulas that, you know, they're going to expect that you know, like it or not. Number 44, a barrel contains 35 liters of solvent mixture that is 40% solvent and 60% water. Lee will add pure solvent to the barrel without removing any of the mixture currently in the barrel so that the new mixture will contain 50% of solvent and 50% of water. How many liters of pure solvent should Lee add to create this new mixture? This might be another skip problem. This was something, thank you, Huda. This was a problem that could have been taught in Algebra 1, but I will tell you students really, really struggle with this one. So I'm going to put a little frowny face here. If you read this and you're thinking, I don't have a clue, skip it. Keep looking for problems that you do know how to do. The answer to this one is going to be 5. And what I did is I looked at, I did 25 at 40%, and then I did 25 at 60%, and I worked this out, and I got 10, and I got 15, and then they wanted to make this equal. So I said we have to add 5 more. Are we doing gallons, liters? Well, I would have to add 5 more to 10 to make it equal to the 60% solvent. So that's kind of a backdoor way to do that one, but that's how I did number 44. All right. Number 45. This is something that we've actually done in Algebra 2. We're trying to solve this equation, or actually we're trying to add the two fractions, and we do not have a common denominator. This little part is just telling us that x is not equal to the opposite of y, meaning we can't have 0 in the denominator. So this really has nothing to do with the problem. So we're trying to add two fractions that do not have a common denominator. So the way we find a common denominator is we multiply those two denominators together. So we're going to have an x plus y and an x minus y. We've done this type of problem this year. This new denominator changes into the old, changes into the new by multiplying by x minus y. So you got to multiply the top by x minus y. This old denominator changes into the new denominator by multiplying by x plus y. So we've got to multiply the top by x plus y. If we distribute this out, we're going to get x squared minus xy, and then we're going to get a plus xy and a plus y squared. These are going to cancel. And then I'm going to get x plus y, x minus y, my common denominator on the bottom. That's going to give me x squared plus y squared over that common denominator, and then that is the final answer, which is E. If we multiply these together, that's going to give us that x squared minus y squared. All right, number 46. I'm going to go all the way to 4 o'clock. If y'all need to go, I am recording, but I'm going to try my best to get to number 60. Number 46, Mary, James, and Carlos sold 1/4 page of advertisements for their yearbook. Mary sold twice as many as Carlos, and James sold 3 times as many as Mary. What fraction of these advertisements did Carlos sell? So I wrote this down. I wrote down Mary, Carlos, and James. It says that Mary sold twice as many as Carlos. So I put X for Carlos. I put 2X for Mary. And then it says James sold 3 times as many as Mary. So 3 times 2x would give me 6x. So Mary was 2x, Carlos was x, James was 6x. If I add all these together, 2x, 1x is 3x, 3x and 6x is 9x. And it said, what's the fraction for Carlos? So Carlos is x. I did x over 9x. The x's cancel, and I get 1/9. Now, again, there's probably multiple ways to do that. That's just how my brain thought to do it. As long as you get the right answer, that's all that matters. That nobody's going to care about your path. Number 47, in the window display at a flower shop, there are 3 spots for plants. So there's 3 little spots for plants. So in your mind, you're thinking that. To fill these 3 spots, Emily has 6 plants to select from. Each of the different types, selecting from 6 plants, Emily can make how many possible displays. So this would be, if she put one of the 6 in this pot, then she would take 1 away, and then she would have 5 left to put in this one, because she's already used one, 1 here and 1 here, and then she would have 4, and then we just multiply those together, and that gives us 120 possibilities. You might remember the sandwich problems where you have ham and you have turkey and you have salami. You have different types of meat, different types of bread, how many combinations of sandwiches. That's kind of 7th grade, 8th grade, possibly algebra 1. All right, number 48. Again, this is a problem where they're giving you some information, and it goes for number 48, number 49, number 50. So it says, in the terms of A and B, what is the area of the triangle MPQ? So this is kind of a geometry problem. Here's MPQ. You would have to know the area formula for a triangle, which would be 1/2 base times the height. It's another formula you need memorized. So the base would be 1, 2, 3, 4, except we're measuring these in A's. So the base would be 4A. And the height would be 1, 2, 3, 4, 5B. And then we would multiply that together. 4 times 5 is 20. Half of 20 would be 10. So the area would be 10AB, which would be G. Number 49. Same direction, same diagram. Number 49 says point M will remain fixed and point Q will move to the right. So M will remain fixed. Q will move to the right. It says, as Q continues to move to the right, what is the following statement that describes the slope of MQ? So this line is now kind of like this, but Q is going to move further to the right. So then it's going to make it go like this. It's going to, it's going to make it more slanted as Q moves to the right. It says A will decrease, eventually be negative, decrease, but never negative. It's going to be B. So this is a negative slope no matter what. It will decrease, but never be negative. I lied. It will decrease, but never be positive. Hold on. It will increase, but will never be positive. Yeah, because this might be like 2/1, and then this is still going to be a smaller slope, but still going to be negative because it's still going to be slanted downwards from left to right. All right, number 50 still goes with this diagram. Don't forget that. One of the following values is equal to F. What one of the following values is equal to F of 5A. This is something we've been doing in Algebra 2 this year. So you're going to go find 5A, which is right here. And then you're going to go all the way up to the function. So when your X value is 5A, your Y value is 8B. So look, this is number 50. And as long as you understand what it's asking you for, that could take you 3 seconds to work. So there's some problems in those last 20 that are not going to take you that long. One of the following values is equal to F of 5A. So you go to 5A on the X, you go up to your function, and you figure out what the Y value is for that one. Okay, that one's kind of like a little breath of fresh air in the middle of all those real difficult problems. All right, 51. I think I'm going to make it. 51 says 12 jurors are needed for an upcoming trial. The diagram below illustrates a part of the process of jury selection. The 12 jurors will be selected from a jury pool of 60 people. That's important. The court records show that the trend that only 40% of the people are summoned. And out of those, only 1/3 are excused. It says if this same trend continues, how many people should be summoned to have as close to possible as 60? So I kind of took the answers 225, and I did 225. I kind of went backwards on this one, and I did 40% of 225, and that gave me 90. And then I took 1/3 of 90, and that would be 30. And I took that away because those would be the jurors that would be excused, and then that would give me 60. So I knew it wasn't these smaller numbers. I knew that those just wouldn't work. And so I probably started with 150, and I started and went to 225 until I got a number that worked with the story. 52, this is not a super difficult, hard problem, but you have to know what's going on. So it says that what is the 275th digit of this number? So this bar represents repeating. So, you know, this goes 0.6295, 6295, 6295 over and 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 over again to infinity. And it wants to know which digit is in the 275th spot. So, yep, who just got it? There's 4 digits that are repeating. So you're going to divide 4 into 275. 4 won't go into 2, but 4 will go into 27 6 times. That's 24. 7 minus 4 is 3. Bring down the 5. 4 will go into 35 8 times. 8 times 4 is 32. And then the remainder that you get is the digit that you would get to. So you're going to get to the 3rd digit. If you got a remainder of 2, then you would get to the 2nd digit. If you got a remainder of 1, you would get to the 1st digit. So since you got a remainder of 3, that's going to be the 3rd digit in the group of numbers that are repeating. So again, that one's not super hard. You just have to know how to work a problem like that. All right, number 53. Given the following f of x and g of x, what are the values of x for which f of g of x equals 0? Okay, so I'm going to kind of work this one backwards. We've been doing some combination of functions. This was towards the end of unit 3, the unit we just finished. This is not adding, this is not subtracting, this is not multiplying, this is not dividing, but it is a combination. So I think I can show you how to do this one. We don't do it in Algebra 2. You'll probably see it in pre-cal, but I think you can figure it out. So you're going to take g of x, okay? So you're going to take all of this, and you're going to put it into f of x. So I'm going to take my answers. So if I do a -5, -5 plus 3 is -2. And then I take -2 and I put it into f of x. -2 squared is 4, and 4 minus 4 is 0. So we're trying to get 0. So this one works. Let's try -1. If I put -1 into g of x first, -1 plus 3 is 2. I put the 2 into f of x. 2 squared is 4. 4 minus 4 is 0. So it just happens to be the first answer. It could be all the way down at the bottom. But I think you could do a problem like 53. Again, it's not something that we study in Algebra 2, but it's similar to something we studied at the end of Unit 3. Number 54, given that p is a positive number, n is a negative number, and the absolute value of p is greater than the absolute value of n, which of the following expressions has the greatest value? What did I do for this one? I made up some numbers. I don't like problems that don't give me numbers, so this is just how my brain works. So according to this problem, the absolute value of p has to be greater than the absolute value of n. P has got to be positive, and n has to be negative. So I just made 2 numbers that made sense with the directions, and then I figured out which one of these would have the greatest value using 5 for p and -2 for n. And this one I came up with G. And again, if you want some more instructions, I'll go back, but I'm going to try to get to all 60 problems. I is equal to the square root of -1. That's an Algebra 2 problem. On this problem, what did I do? I just started looking at what I knew. So I did I, that's in the problem, plus this I squared. I left it there for just a minute. And then I changed I cubed into I squared times I. Because remember, anytime we have an exponent on an I, an imaginary number that's odd, we subtract 1 from it and rewrite it as I squared times I. So because we know what our I squareds are equal to. Down here on the bottom, my I cubed, I turned it into I squared times I. My I to the 4th, I turned that into I squared times I squared. And then my I to the 5th, since 5 is odd, I turned that into I to the 4th times I. And then I started just changing all my I squareds into negative ones. I and I is going to give me 2I. Minus 1 and minus 1 gives me minus 2. This is going to be negative 1 times I, so that's going to be negative I. This is going to be negative 1 times negative 1, which is going to be a positive 1. This I to the 4th is the same as negative 1 times negative 1, so that's going to be 1 times I. So that's going to be I. The minus I and plus I are going to go away. And I've messed up somewhere because I should have I plus I, 2I. I've got a number out of place. This one is negative 1. Let me see if I can find my mistake. If y'all see it, let me know. Oh, this
Ms. Prater, I found the mistake.
Tell me, please.
You said negative 1 and negative 1 in the denominator, and negative 1 equals negative 2 and 2, not plus 1.
Well, this is times.
Oh, I didn't see the symbol.
Yeah, I think my mistake is in the top. So I did I, and then I did plus I squared, and then I did plus I. Oh, I know. So this would be I plus negative 1 plus negative 1 times I. So that's going to be I minus 1 minus I. The I and the minus 1 cancel. This is not what the top is. The top is negative 1 over 1, which comes out to be negative 1. This is a really hard imaginary number problem, but basically what you're doing is you're simplifying your anything with an exponent of 2 or more. You're simplifying that using the rule that I squared is equal to a negative 1. So it's kind of all based on that fact. 56, you could actually put this into a graphing calculator if you have that available. I already have it in my graphing calculator. You might not have known that you could get graphs like this, but I put both of these equations in exactly like how they were. And we're looking for where the graphs overlap. So the red graph is the line. The blue graph is the circle. And so they're overlapping in this area. Since this is red, this is not overlapping. This is the blue. This is the mix of colors right here. So you're looking for this graph. So yeah, you couldn't do this unless you were, unless you had a graphing calculator. So on this one, it would be K. All right. 4 more. Oh, 1 minute. I can do this. 57. I'm going to go ahead and tell you the answers for these. If y'all need to go, you can, and then I'll go back and talk about them. 57 is D. 58 is a cosine graph. This is something that we definitely have studied, sine and cosine. 58, the answer is K. I'll tell you on this one really quick. You're going to look at the period. This graph has a period of pi. And remember, you have to find your A, your B, and your C. A is going to be where your midline is, and your midline is at 0. C is going to be where your midline is, and your midline is at 0. A is going to be your amplitude, the distance from the midline to the max and the midline to the min. So that's going to be 3. And then you'll use your period. Your period is pi. It's equal to 2 pi over b, and you'll figure out what that is. You'll cross multiply, or you can figure it out in your head. And b is going to be equal to 2. And so that's going to match with k. All right, 2 more. Number 59, I got B. This is the law of sines problem. We're trying to find this distance of the string. So we would do sine of 45 over x equals we know this angle is 60 because all three angles add up to be 180 in any triangle. So this would be sine of 60 over 240. And solving that problem gives us x, which is 80 square root 3. And the last one is f. And I set up an equation. I said that y was books sold and y minus 1 was additional copies, I think. And then I set up this equation. I did 15 plus 12 times y minus 1. And then I distributed, combined like terms, and got 12y plus 3. Okay, 4:02, 2 minutes past. Awesome. Thank y'all so much for coming. If you want to stay around and you want me to go back to one of those problems and slow down a little bit, I'll be glad to do that. Remember the ACT, go in, do the very best you can, get a good night's sleep the night before. You don't have to get every single problem right. Answer the ones that you can, skip the problems that you don't know how to do, come back with a little time left. Make sure that you answer all the problems, even if you have to guess, and then feel good about yourself that you did the best you could, and move on to something else. Try not to stress yourself out about it. Anybody want me to go back to a certain problem? Yes, I can do that. All right, Z, I know that you had a question. So I'll send Z. I'm not sure what room Z is in. I'm going to stop sharing. If Z is still here, let me look around. I don't think Z is still here. Hey, Lily, yes, we can schedule a one-on-one. I have to change the size of the tables. Just a second. I got to go to settings. I've got y'all set for 1 for each table. So let me do 2. And Huda and Xander. I wonder why I didn't do that. Hold on. 2. Let's see if I can let y'all move yourself. Hold on. Oh, I know where that is. It's not there. It's seating arrangements. Free seating. Save, apply, create random seating, lock tables. Can y'all move yourself to table 5? Do y'all know how to move yourself? There we go. Okay. All right. You're welcome, Megan. All right, Lily, let me tell you what I have available. Let me pull up my schedule for just a second. So tomorrow I am available at 8 or 9, and then I actually have workshops the rest of the day. So if that's too early for you, we could shoot for next week. Would 8 or 9 work, or do you want to try next week, Lily? You want to do 8 or 9? 9 would work better for me. It would give me just an hour. Okay. All right. I'll go ahead and schedule you for 9. And just make sure that you attend. I'll mark it required. Okay. If something comes up and you can send me a message before, like 15 till 9, I can cancel it and then we won't be docked for you not coming. Does that work? Awesome. Any last minute questions? All right, guys. Y'all have a great day. Thank you.